Record. Hello and welcome to our Capstone 2 presentation. My name is Ted Holden, and together with Dalen Blakely, developed a new weather data display and graphing software solution called WonderWeather. The SOU Science Department owns and operates a professional weather station located in Ashland near the ScienceWorks Hands-On Museum. Jamie Trammell and Vincent Smith are science professors in charge of this weather station. They came to Radarsoft in hopes of developing a custom software solution for two main reasons. The current software solution for the weather station does not store data long-term, and in addition to this major limitation, the website component relies on Adobe Flash Player, a web browser plugin that later this year will no longer be allowed by most browsers or supported by Adobe. In the beginning of the project, we assessed the current system as a whole and determined that the software in use, called the weather display, was doing an acceptable job of interfacing with the weather station hardware, as well as forwarding weather data to the NOAA and other external entities. Weather display also had the ability to upload weather data to a remote SQL database, which had not yet been utilized. We decided to focus on a data storage solution and a new website that would work in conjunction with weather display. Our goal was to create WonderWeather, a software solution that would store weather data indefinitely, display current weather data, and create custom graphs of this data in the form of an easy-to-use, visually pleasing website. This is a screenshot of the current weather.sou.edu website, and we used it as a guide and loosely modeled WonderWeather Live, the WonderWeather Live display off of it. Our goal was to incorporate most of the features of the current website so that we have the same functionality, but that users would be familiar with it. The longtime users would be familiar with it, but with the added ability to create graphs of the archived data. Another big limitation was the iOS or any device that did not support Flash. When they went to the website, they had to click another link to go to this website, and it had just a visual representation. So it was a big downfall of the current system, is just using Flash in general, and the portability was not there.
All right. So at the end of the winter term, we had managed to make some progress. We acquired access to and set up a virtual server in the SOU IT department, which could store weather data in a MariaDB database and also host our website. We created a Python Flash program to act as the web server and a simple Python program to query the weather database and retrieve the most recent data. This data was displayed in a basic web page that used a plotting library called Plotly as its graphing engine. We also began to work on a Python program that would continuously query the database and write the most recent weather data to a JSON file to create an API. This would make it so that users visiting the website would access the API instead of directly querying the database. This would take the load off the database by requiring only one query per minute instead of potentially many. Throughout Capstone 1, we also worked closely with our clients, Jamie and Vincent, to define the system requirements and features of WonderWeather, and we are well on our way by the conclusion of the term. Here's a screenshot of our first iteration of the WonderWeather live display. While it was functional, it was not exactly pretty, and under the hood it relied on direct querying to the database. As I mentioned, this approach was inefficient and put more strain on the database engine with increased users. So this is the next iteration of the weather display. This is at the end of the winter term, this was our live display. And as you can see, it's a little more aesthetically pleasing. We actually got a new charting library called AnyChart that we decided to use for the live graphs instead of Plotly. And after making that decision, any chart became a huge part of our project. All right, so for Capstone 2, we set out to improve on the progress that we had in Capstone 1. We were going to improve, or our goals were to improve on the visual representation of the data in the web page, make the web page more responsive to different screen sizes, add non-functional elements from the old site, including picture of the weather station, a map to the weather station, and some contact information. We also set out to add more functionality, including unit conversions, um, plots for custom time intervals, and more data displays.
Okay, thank you, Dylan. We used several other Python and JavaScript components in addition to Flask, Plotly, and AnyChart. Those were the big ones. We also used PyMySQL, PyLunar, Suntime, Bootstrap, jQuery, just to name a few. And I wanted to give an example of a problem that we were able to solve using one of these tools, and that is the date picker functionality of the website. Most browsers actually have a date picker built in that will display a calendar for users to pick the date, the month, the day, the year. However, Safari is one, and it's the default browser on Macintosh, and it doesn't have a built-in date picker. I learned this doing this project. So using jQuery, we were actually able to quickly implement a date picker for any browser that doesn't have one of its own. And this is an example, a small example of how we used available tools to make the website more user-friendly, regardless of what device, operating system, or browser a user might be using.
All right, so the next few slides are a couple screenshots of a few different iterations of the live display that we had. And in this screenshot, this is just pretty much a screenshot of the live display at the start of the spring term. Each of the gauges in this iteration were all contained into one element that was displayed on the page. And when the browser size changed, or you viewed the site from a phone, the graphs would overlap and wouldn't be as readable. All right, next slide. So this is a later iteration where we went in the direction of using a grid layout, and the grid layout allowed us to separate the gauges a little better. And also, when the browser resizes, the grid rearranges itself and allows each of the gauges to be clearly displayed. All right, next one. So this is one of the later iterations for the spring term. As you can see, we added a navigation bar that lets the user switch between tabs. There's also some buttons down below, which ended up being buttons to allow the user to switch between the units for each of the gauges. And as you can see, we continue to use the grid layout, but there's still some open space where we were still working on adding a few pieces of data. All right, and this is a screenshot of the final iteration when the browser size is shrunk down to the size of a phone. And as you can see here, the grid kind of rearranges itself so that each of the gauges can be displayed clearly and none of them overlap each other. And Ted will show a video of a demo.
Here is the new prototype SOU weather station website powered by WonderWeather. You can see the current weather conditions, including temperature, humidity, barometer, wind direction and speed, dew point, solar radiation, yearly, monthly, and daily rainfall, in addition to information about the sun and moon rise and set. It has an indicator of when the latest data was retrieved from the database. And over here on the sidebar, I'm going to start with these unit conversions because these are really handy. If you want to display temperature in Celsius primarily, you're able to click that. If you want to change the wind gauge to knots, you're able to change that. I like Fahrenheit. I'll switch it back. Miles per hour. That's easiest for me to read. Now, if you go up to the top of the sidebar, we're in the weather display right now. There's a really neat feature, past 24 hours. We plan to expand on this page, adding more than just temperature. Right now, you can see the past 24 hours, which is really handy. It has the highs and the lows and the current points as you move your cursor over them. Now, the custom graphing tool, this is a little different. It uses Plotly. That last graph uses any chart. I'm going to select a date. I'm going to go back to the beginning of when we started collecting data, which was mid-February. Today's date is the 11th. Oh my gosh. I'm going to check temperature. I can choose these different parameters or attributes. And we have a choice between imperial and metric. So it's a little more general here with the units, something we'd like to expand on as well. And I click submit. Keep in mind, we're in a remote desktop connection. There might be a little bit more lag than normal, but it's pretty snappy either way. So this is temperature in Fahrenheit. Going back to the very beginning of the data, when we started putting data into the new database, I'm able to use my mouse since this is a Plotly graph, similar to any chart, but I can move my mouse to see the exact points that I'm hovering over. What's really neat is I'm able to grab my cursor and zoom in on a chunk just to get a closer view of a certain span of time. And I can also save the graph to my computer using this link. There's some other tools over here that are pretty neat. Those are Plotly features. I'm going to go back and show you another really neat feature about the custom graphs. If we change this to this combination graph, I feel like this is going to be really handy for science folks and regular folks as well. I hit submit. This is basically the main attributes from the whole time we've been collecting data. You're able to see temperature, humidity, barometer, rainfall, all in the same window. So I feel like this is going to be really handy. Back at the main page, we have a really neat little info page that has a picture. This is the actual weather station. An antenna beams all the data back to the main SOU campus, which in turns makes it to our database and back for the weather display to display it. A map, interactive map, and we got our GPS coordinates as well as some handy links. There's a little about page, which is neat. It has Dalen and myself's contact and some other information. And what is really cool about the site is the scalability of it, and something that is much better than the other one. I'm going to attempt to click over into what the emulator for the phone would look like. So if I'm on a phone and I'm in portrait mode, I'm able to look at it with a phone visually. Before, using Flash for iOS folks, it wouldn't visually show you anything. It had a text layout, but this is really neat. It works great on a phone. Huge improvement. You have your sidebar still, but it's you have to click to get the sidebar. So that's the brand new prototype for SOU and their weather.sou.edu site. And I'm going to conclude this video right there.
Okay. Testing WonderWeather. I'm going to get into testing now. It's been a continuous and constant process for this project. One difficulty we ran into with the COVID-19 pandemic was that we no longer were able to physically be on the SOU campus. For security reasons, the school server was not fully open to outside connections, and we had to adjust our workflow a bit. We were both able to install databases with a snapshot of the data on our personal computers and test the code as we went along. Towards the end of the term, we spent a lot of time comparing the data being displayed with the data in the database and checking and double checking our conversion factors, units, and calculations to try and make sure that we were seeing
what we were seeing was an accurate depiction of the data.
As for the division of labor, I primarily focused on the live display and layout of the web page, where Ted focused more on the custom graphing tool, quality assurance, and communication with the client and IT department. The live display required at least a small majority of the coding, so Ted took on the role of coordinator and quality assurance to make up for this difference. We both worked well with each other and have enjoyed working with Jamie, Vincent, Fabrizio, and the SIU IT department on this ongoing project. All right, in conclusion, not only has WonderWeather come a long way since our first meetings with Jamie and Vincent in the beginning of the winter term, but we as students, software developers, and friends have as well. We have created a great working relationship with each other and have learned a lot about not only coding, but about working as a team, together as a team, and with our clients and supervisor. We're hopeful that WonderWeather will indeed replace the current weather.sou.edu website, and that SOU and the public will be able to use it for many years to come. There are several future enhancements that we would like to see implemented in the next version, including the calculation and display of evapotranspiration, improved display of highs and lows in conjunction with the live data, and expanded graphing capabilities. In the future, expanding WonderWeather's feature set to fully replace the weather display application would give it the potential to go from a useful tool for SOU to a fully functional software solution that could serve a larger market base. Environmental monitoring technology is an exciting sector and is relied on by millions of users around the world. Getting to work on this project has given us an amazing opportunity to see some of the possibilities, and we feel very fortunate for the opportunity. Thank you.
Thank you.